Thank you. Let me know once you're able to see my screen.
We can see it.
Hey everyone, very good evening. I welcome you all to my session today. I hope you and everyone in your family are staying safe and staying healthy. My name is Vaibhav Gujral. In this session, as Kevin was mentioning, we'll touch upon Azure Well Architected Framework. This session is going to be a high-level overview of what Azure Well Architected Framework is. It's not possible to cover each and every pillar and aspect of a framework within 1 hour, but I would try my best to ensure that by the time the session ends, you will have fair understanding of what well-architected framework is and how you can get started on with it. With that, I just want to let you know I have 3 monitors in front of me. I'm sharing my presentation on two, right on the right side, and on the left side I have Teams window open up. So if you have anything to ask me, feel free to unmute yourself and ask, or you can use raise your hand feature in Teams. You can post your comment in chat, and I will keep on checking the comments. Okay, as in between my slides, and I'll try to respond back. And I do see a question by Bob. Yes, the slides I can share slides with Cameron and Kevin, and I'm not sure if they can probably share it with you all. With that, let's get started. Quick intro about me. I'm based out of Omaha, Nebraska in Midwest. I work as a cloud architect at Kivet Corp, which is one of the largest construction companies in United States. I'm a Microsoft MVP. I'm a Microsoft certified trainer. I hold several certifications in Azure. I do run Omaha Azure User Group, which is a group similar to this particular user group as well. We are on Meetup, and we also have our YouTube channel. We conduct bi-weekly meetings as well on Azure related topics. I regularly speak at different events, user groups, and conferences on Azure related topics. You can see my blog address uh, listed down there. You can check that out. I do try to post occasionally on my blog. You can always reach me on my Twitter handle or on my LinkedIn profile if you have to reach out to me offline. So let's talk about well-architected framework. And before we actually jump onto that, I would like to ask each one of you to answer this question for me. Is your cloud environment well architected? Is your Azure environment well architected? Does it has all the characteristics that are required to be qualified as well architected or well designed environment? If you know the answer, you can go and raise your hands. If not, I'm sure some of you might be confused, but we don't know what well-architected cloud environment means. So in a nutshell, in just single slide here is how I can define a well-architected cloud environment. A well-architected cloud environment is cost-effective. It maximizes your return on investment. It is built and designed using modern DevOps practices like CI/CD. You have infrastructure as code. You have automation pipelines in place. It delivers high performance and uses the right set of cloud resources in achieving that level of performance. It is reliable and fault tolerant. In case of an outage or a disaster, it fails over and ensures the business continues without any major impact. It is secure, most importantly. So if your cloud environment has those five features or characteristics, then you can qualify your cloud environment as well architected. So if you have got an idea on what a well-architected cloud environment might look like, I'll go back to my question and ask this question again. Does your cloud environment is your cloud environment cost effective? Is it reliable? Is it secure? Does it offers high performance? Is it built and designed using modern DevOps practices? Don't worry if you can't answer right away, or if your answer is no, because that's true for most of the organizations. Likewise, if you have not moved to the cloud yet, or you are now planning to move to Azure, then it becomes essential for you to architect and design your cloud environment the right way with all the considerations for all the different characteristics that I did listed in my last slide. And if you will well architect your cloud environment, your Azure environment, it will pay you off really, really well over the long run. Before we jump onto well-architected framework, it's based on 5 core pillars that rely on the 5 characteristics I was mentioning in one of the earlier slides. I want to talk about shared responsibility model. When we speak of any public cloud, it is very, very essential to understand that cloud works on a shared responsibility model. If you think of moving the workloads to the cloud, to the public cloud, will make the cloud provider responsible for everything, then you are mistaken. It's a shared responsibility between you as a consumer and the cloud vendor. Unlike a traditional on-premises environment that you are seeing towards the left, where you are solely responsible for everything, based on the cloud service model that you opt for towards the right, the cloud provider actually manages certain aspects of your workloads and some of the other aspects fall onto you. So if you are running your services in infrastructure as a service or IaaS, then the vendor is responsible for the physical infrastructure and virtualization. You as a consumer is responsible for patching your operating system, updating middleware and runtime, and last but not the least, you own your application and data, so you own and manage those. When you move one step further and you start using platform as a service, then you just own and manage your application and data. Cloud vendor manages the physical infrastructure, the virtualization layer, the operating system, and the runtimes and libraries running on top of it. Then under the last service model known as software as a service, cloud vendor manages everything from the physical infrastructure to the application, and you just consume the application and data. As you can see here with each service model, the responsibilities are shared between the consumer and the cloud provider. This shared responsibility plays a key role in your architectural decisions because these decisions can have implications on cost, security, and the technical and operational capabilities of your application. By shifting these capabilities to the cloud provider or the cloud vendor, you can focus on really bringing the value to your business and move away from the activities that aren't a core business function in your organization. So let's talk about Azure Well-Architected Framework. As I was saying earlier, it's a set of 5 core pillars to help enterprises build high-quality solutions on Azure. Microsoft has not invented any of these pillars or the framework. Instead, these are built on industry standards and recommendations. In fact, Amazon and Google also offer similar framework to help you design your cloud environments the right way. In fact, Amazon calls their framework as also well-architected framework. And if you will go and check that out, they also list the same 5 pillars. Now, there is no one-size-fits-all approach to designing an architecture, but there are some universal principles that will apply regardless of the architecture, technology, cloud provider, or business use case. So these concepts are not all inclusive in themselves, but uh, baselining your cloud architecture on them will really help you in building more secure, more reliable, more flexible foundation for your overall Azure environment. As you can see in the slide, Azure Well-Architected Framework consists of 5 core pillars: cost optimization, operational excellence, performance efficiency, reliability, security. So as the name suggests, under the cost optimization pillar, the recommendation is to design your Azure environment so that it is cost effective for operations as well as development. Basically, you ensure that you are spending money where you get the maximum return on investment. In the process, you bring in efficiencies in your cloud spend and avoid any wastage of your dollars. Under operational excellence, the recommendation is to take advantage of modern development practices, aka DevOps, which results in faster development and deployment cycles. Then you also need right monitoring strategy in place so that you can detect failures and problems before they happen or before they are noticed by your users or consumers. Automation is also another key aspect of operational excellence pillar. Under performance efficiency, the recommendation is to properly match resource capacity to demand so that your workloads can perform well and can scale as needed. So scalability is what makes your Azure environment performance efficient. Azure offers a feature known as Autoscale, which lets you scale resources up and down dynamically based on the activity that's happening in your application. In a nutshell, the recommendation under performance efficiency is to design your architecture with performance and scalability in mind. Next on the list is reliability. As the name suggests, it recommends to design the system with while anticipating failures at all levels. Tell me, what's the greatest fear of any IT team?
Data hack.
Outages.
Outages. Well, that's the biggest fear that I'm aware of, because it's the fear of system going down with no way to recover it. And failures are inevitable. Failures can happen anytime, anywhere, right? And moving your workloads to cloud, no cloud providers offers SLA of 100%. They offer 3, 4, 5 nines, but still it's not 100%. So chances are outages might happen, resources might go down. So they are bound to happen somewhere, sometime. So the reliability pillar recommends to design Azure environment in such a way that it doesn't fails at the first place. And even if it fails, it recovers from the failures within the stipulated time graciously. And last but not the least, I think security is a no-brainer. Uh, Security, the shared responsibility model that we discussed in the last slide, also applies for the security as well. Based on what we as a consumer are responsible for, we need to architect our cloud Azure environment with the right set of security mechanisms in place. Uh, there are certain security features that Microsoft as a cloud provider or cloud vendor manages. And then there are certain aspects that we as a consumer should be aware of, and that is where data encryption or protecting our applications against distributed denial of services attacks come into play. Another important aspect to security is identity. We should secure our identities so that no one can really hack and enter our environment and make damage our give us a damage or impact our overall environment. In the next few slides, we'll touch upon each of these pillars in depth. So if you have any questions, feel free to ask me or send it on the chat. I will keep on responding. I don't see anything yet, but moving further, before I move further and start talking about each of these pillars in depth, Microsoft does offers an assessment or a review for well-architected framework, which you can go and do it yourself against your environment and come up with the right set of recommendations. I will be demonstrating it towards the end of the presentation to show you how you can do it yourself. Let's talk about the first pillar in more details: cost optimization. Cost is always an interesting factor, in my opinion. Whatever decisions an organization takes, cost always plays a key role. Same applies for even cloud computing. When organizations are moving to cloud or Azure or AWS or any public cloud, cost does plays a key role, because there are no free lunches. There is nothing free in cloud when you run any resources. So utilizing cloud computing for your business needs a shift in that mindset, because when you are running your workloads on-prem, you utilize a model known as CapEx, which is called as capital expenditure. Under CapEx model, you pay your cost upfront, you procure hardware, you bring in hardware into your data centers, set it up, and then you can also take tax benefits based on that cost. But when you're moving to public cloud, that changes. You don't really have to pay anything upfront. You move to a model known as Opex model, where you pay on a monthly basis for the resource consumption, the resources that you are consuming in the public cloud. So in a nutshell, moving to cloud changes the dynamics of how cost work for technology. So I've heard from so many different customers that they don't really plan for the costs well in advance for public cloud consumption. And when the monthly invoices start coming, they are surprised and shocked. So be aware of that shift in the mindset from CapEx to OpEx when we are moving from on-prem to public cloud. And that's one of the motivating reason to consider our first principle, because cost sometimes, as I was saying, I've heard of so many customers who get surprised by their bills. So the very first principle that goes under cost optimization pillar says planning and estimating your costs. Before you provision anything in Azure, plan and estimate your costs upfront. You can use any cost estimation tool of your choice, which gives you a holistic estimate of your total cost of ownership to move to cloud. You can use pricing calculator offered by Microsoft on Microsoft Azure's website, which you can utilize to get an initial estimate of monthly cost for your design. If you are an enterprise agreement, if you have an enterprise agreement with Microsoft, you can apply that discount as well on that pricing calculator and see how much it's going to cost you. So what it essentially does is it ensures that you don't get shocks at the end of the month in your bills. It is very essential to estimate your costs upfront and inform business about the estimated cost for running your workloads in Azure. Next principle is around cost optimizations. Once you have planned and estimated your cost, you go ahead and you deploy and provision your resources. Always provision those with optimization in your mind. It is just not enough to estimate the cost because you get a fair idea of how much it's going to cost. You should also keep looking for ways to optimizing your spend in Azure. By optimizing your Azure spend, you can maximize your return on investments. There are many considerations to optimize your cost. For example, you should answer questions like, should we consider running SQL Server on a virtual machine, or should we use Azure SQL Database, which is a platform as a service offering? Can we utilize options like reservations or hybrid benefits to bring down our licensing cost or bring down our overall infrastructure cost? So under the second principle for provisioning with optimization, keep considering those different aspects to bring down your overall spend and increase your return on investment. The third principle under cost optimization is around monitoring and analytics, which feeds directly into the second one. You must leverage monitoring and analytic tools available at your disposal to monitor your cloud spend and generate insights out of it. By looking at historical cost information, you can easily identify the areas where you can reduce your cost and eliminate any wastage. Azure offers, if you're not aware of, Azure does offers a full-fledged cost management solution, which makes all the cost information available to you in a rich interface within Azure portal. It lets you not only see the historical cost, but it also gives you a forecasted view of your future costs based on your historical trends. You can further filter your cost based on subscriptions, resources, resource groups, and different other filters. In a nutshell, what it essentially enable you is to have enough visibility into where your dollars are going into public cloud consumption, and it helps you understand how you are being billed for consuming those cloud services. It might give you some insights into where you can go ahead and optimize your costs and save some dollars for yourself. Lastly, what hurts the most under cost optimization is those unnecessary expenses that could have been easily avoided. The last pillar addresses that concern. You must put in time in identifying those leakages. The sooner the better it is. In most of the cases, the reason for wastage is wrong sizing, where resources are provisioned uh, with way more capacity than what they need. For example, you might have virtual machines which could be underutilized, meaning the average CPU consumption for the virtual machine might be just stagnant and under 20%. It might be an ideal candidate to be downsized. It's not only the infrastructure cost, it could also be operational cost as well. You can bring down your operational cost by automating your deployments. So think of different ways how you can actually maximize efficiency of your overall cloud spend. Always right size your infrastructure. Always start with the small and then move on. So in my opinion, in a nutshell, cost plays the most important role in your architecture. While you are designing your Azure environment, always be cognizant of the spend. Do utilize pricing calculator, get an estimate, start small, provision with optimization, utilize cost management to see the trends and identify pockets of improvements where you can really optimize your spend. Here are some of the quick ways you can actually improvise on your cloud spend. Most of them are self-explanatory. I will just read out one by one. The first one is around shutting down the resources which are unused. Always remember that you are billed for what you provision in Azure, regardless of the usage. Even though it says pay as you go, pay as you use, but it's in my world, what I have understood is it is pay as you provision. The moment you go ahead and provision a virtual machine, Microsoft will start charging you. They don't really worry about if you have been using that virtual machine or not. So always be aware of the usage and shut down any resources that are not used. The second is around right sizing. You should always right size the underused resources. Don't allocate capacity more than what is needed in your environment. As a thumb rule, as I was saying in the last slide as well, I always start with the smallest size that I think is the right for my workload. And then I utilize monitoring tools to keep monitoring my workload and see how my resources have been behaving. Let's say if I have a virtual machine, I keep a track of the CPU consumption, memory consumption, so that I can see if my virtual machine is underutilized or overutilized. And as and when I get enough data to justify scaling up the resource to the next, I do go ahead and scale up the resource to the next size. If you're an enterprise customer for Microsoft, you can also leverage reservations and Azure hybrid benefit to bring down your cost substantially. If you're not aware of reservations lets you book capacity upfront and at a discounted price. And hybrid benefit lets you take your existing licenses from on-prem to cloud. So if you have not been leveraging reservations and hybrid benefits, I would strongly encourage you to go and check that out. I did mention about auto scaling in one of the earlier slides, but auto scaling is a very nice feature to handle fluctuating workloads. You can utilize auto scaling, which can scale your resources up or down, and you can actually save your cost for the resources. Because, for example, take an example where your application is just used during 8 hours of the working days. It's not consumed for 16 hours during night. It's not being used over the weekend. So you can always scale it down to lower number of instances and save your money over the time where the load is not high. Last but not the least, you set up the budgets and cost allocations, which help you make costs visible and make people accountable for their Azure spend, and always choose the right compute size. You might be better, as I was saying in the last slide, you might be better off using a PaaS offering for SQL database rather than running a full-blown SQL server on a virtual machine, which might cost hundreds of dollars. I can run a SQL database PaaS offering for roughly around $10 a month, whereas a virtual machine might cost $200. So be cognizant of some of these options through which you can optimize your spend. Moving on to the next pillar, operational excellence. Operational excellence is all about ensuring that you have full visibility into how your application is running and ensuring the best experience for your users. Operational excellence includes making your development and release practices more agile, which allows your businesses to quickly adjust to changes. There are several principles that go under this pillar. The first one emphasizes on designing, building, and orchestrating with modern practices, aka DevOps. You must leverage processes like infrastructure as code, automation testing, automated deployments wherever possible. Always remember that DevOps is more about culture than technical areas. You need to drive the cultural change in your organization so that DevOps is embraced regardless of the size of your organization or the development practices that are followed. DevOps can be embraced and built into the system. Second principle, similar to what we had in cost optimization, you should utilize monitoring and analytics to gain insights. You must have a monitoring, logging, and instrumentation system included in your overall architecture so that you can gain visibility into what is going in your environment. You can use cloud native tooling like Azure Monitor, which includes log analytic workspaces and application insights, or you can also leverage any third-party monitoring solution. Having a stable monitoring solution established in your architecture can pay you multifold. It can help you troubleshoot and resolve performance issues. It can help you generate insights on usage information of your workloads and so on. Next on the list is automation. I can keep on telling you about the benefits of automation and the next 45-50 minutes will be over. Automation is a no-brainer for sure. It helps bringing operational costs down, but it also reduces errors in your process as the amount of human intervention is reduced. Automation can help you ensure that your activities are always performed the same way in a repeatable manner. For example, application deployments or resource provisioning can be automated and be implemented in a repeatable manner. Last but not the least, the most underrated aspect of operational excellence is testing. I would be surprised if anyone who is attending this session comes to me and say they have not seen an angry customer finding bugs in the production systems. 99% of these situations can be avoided if testing is included in process to catch mistakes before they impact the real users. Having a reduced number of reported issues by customers certainly improves overall user experience, and that's one of the key principles that goes under operational excellence. I'm sure everyone in this meeting today would have seen a message like this when your
Just a quick
application
question,
goes
if I
down.
could.
Go ahead.
On that last point, the testing,
Mhm.
adding in testing into whether it be your automation or your operations. Do you have any examples or suggestions for testing platforms? You know, is like Selenium a good option for web apps, or is this just depends on what application you're looking, what part of the infrastructure you're looking to test against?
I think it depends on different application and the platform you are looking for
Mhm.
test. The overall principle doesn't recommend any specific tools, but it does recommend uh, the it does recommend that you should have appropriate testing phase included in your overall process so that you can minimize any bugs reaching out till production.
Okay, so like someplace in the pipeline, you deploy SQL database and then have some testing that runs against it to make sure it's succeeded, or you know whatever you're deploying, include that as part of that pipeline.
True, and it might also mean Selenium or even for your API testing. I don't know a whole set of tools, but I believe there are for different kind of applications. There are different kind of automation tools that you can utilize.
Okay.
Yeah, I was asking about this particular message. You would have most of you would have seen this message when your application goes down. If you have not seen in your application, at least you would have seen those fancy online shopping days like Prime Days or whatever, when the average volume of users for those e-commerce websites goes 100 or 1,000 or 10,000 fold. The sites just are overwhelmed with the incoming load and they just stop responding or they become unreachable. So it has nothing to do with their application code or their website code. It simply has to do with the underlying resource capacity and scalability. Due to the increased volumes or loads, it really stresses the underlying infrastructure. And as a result, the site either becomes too slow or it becomes unresponsive because of that kind of load was not planned for or was not tested before. And to address this concern, the next pillar comes into the play, which is known as performance efficiency. In a nutshell, performance efficiency refers to matching the resource capacity with the demand. And if you will think a step back and think about one of the benefits that you get out of cloud computing is scalability, because it, in theory, what public cloud offers is infinite infrastructure available at your disposal, which you can keep on scaling based on your needs. So that's the pillar that performance efficiency targets as well. Performance efficiency includes scaling your resources, identifying and optimizing potential bottlenecks, optimizing your application code for peak performance. There are some core principles that you can leverage under this pillar as well. The first one is around scalability. It speaks about scaling up and scaling out. It is very important to understand the difference between scaling up and scaling out. Compute resources in Azure or in any public cloud can be scaled in two different directions. Either they can be scaled up or scaled out. Scaling up is adding more resources to a single instance. For example, if I have a virtual machine instance, I can add more CPU power or more memory to an existing virtual machine. If it's, let's say, if it's running in DV1, DV6, DV16, I can make it DV32 to get more CPU and memory to my instance. Whereas scaling out is adding more instances. Instead of making a single instance more powerful, I can create replicas of my instance and load balance the incoming request across those instances. And if you will think about it, scaling up actually has certain limitations because you can scale up your infrastructure resources up to the limitations that the physical infrastructure has. You cannot really go infinite CPU or infinite memory on your single instance, whereas scaling out does gives you an option. It does it does theoretically ensures that you can add as many instances you want to add, you can add it in your system. But be aware that as you scale up or scale out, it does impact your cost. And as I was saying earlier, that cost plays a key role in your decision making. So every time you scale up or scale out, always be cognizant of the fact that you are increasing your overall spend. You can leverage a feature, as I was mentioning earlier as well, which is known as Autoscaling, which is not supported across the board, but it's supported for some of the key resource types in Azure. And you can utilize auto scaling, which scales up or down your resources automatically based on the activity in your application. You can really optimize your cost by utilizing auto scaling because you only provision resources as and when they are required. Next on the list is optimizing network performance. When you're working on achieving an optimal performance out of your overall environment, networking resources play a key role. You have to plan and design the right set of networking resources to ensure that there are no network latencies or any kind of performance issues related to networking. You might also leverage messaging patterns to make your subsystems loosely coupled. You can use services like uh, service bus queues. The benefit you get out of having a messaging layer in between your subsystems is that your receiver subsystem takes more time to process each request than the rate at which the sender subsystem is sending the request. Your system doesn't fail in that scenario. Your sender keeps writing message in a queue or any other messaging service, and the receiver just keeps on picking up from the queue. Similar to the networking, storage performance also plays a key role in your overall performance of your system. Speaking of storage, you should choose appropriate partitioning strategy so that you can maximize the benefits. If your partitions are not balanced, it might hit the performance of your systems really hard. Having right partitioning strategy can also make it easier to scale your system and improve overall performance. You must also consider caching to improve your performance of your system. Azure does offer a few options for having caching included in your architecture. One of the most common ones that I have used is Redis Cache. Last but not the least, it's important to identify the performance bottleneck in your system. These days, systems are complex and can have many subsystems. Performance of each of the subsystems contribute to the overall performance of your system. It is important to have right set of performance monitoring in place so that you can measure performance of different parts of your system, be it storage, compute, or networking. Not only at the infrastructure side of things, your applications themselves might be the cause for low performance. Hence, it is critical to have right set of monitoring built into your environment so that you can pinpoint the problem and you can fix them. In my opinion, it's a no-brainer that your cloud applications must deliver high performance, and you must utilize the right set of principles and design patterns in your architecture to ensure that you receive optimal performance for which you are paying for.
I have a question about scaling, scaling up, scaling out, auto scaling. I'm interested to know how you think about that, meaning it could be fairly simplistic. As an example, you might say, when my CPU hits 35%, I choose to do X. It hits this percent, I choose to do X prime or something along those lines, when in fact it seems like it's a little more complex than that. So thinking about thresholds in, like, what are the influences that you would consider if you were going to set up some auto scaling? You would say, well, when memory is this, when traffic is that, number of web requests look like this, CPU is stressed at this level, that would be the indication that I would auto scale and add a new instance. And as long as it was above that threshold, with all of those influences true, that instance would stay there, and it would get torn down when it went below. I know that it feels to me like there's much more of a science to that than just something so simplistic like if utilization of the CPU goes to a level.
Absolutely, and I wish if it could be that simplistic, but yeah, to your point, yeah, it might get complex because it's just not CPU, and if you are setting those threshold rules in your auto scaling rules, then certainly it might get complex. So yeah, I agree with you. Is that specific question that you have for me that I can help answer?
I was interested how you think about it. What are the influences and what are the things you take into account as you're thinking about auto scaling? That's what I was asking.
Primarily CPU and memory consumption is what I have used in the past.
Okay.
I might also say, I mean, it does depend on the solution. Often, though, if you're in event-driven systems and you have an ability to see a queue, you can trigger scaling based on the incoming message rates, as that's usually a leading indicator. And often scaling does require some time to provision and scale up new things. So you have to be very thoughtful about the thresholds that you want to set those to. Like setting it to 98% is probably a pretty bad plan, but 70%. Based on how dynamic your particular workload is, might be too conservative. And the one thing that I will say that you noted is if it scales back down, usually you have a alternative setting for when you scale back from when you scale up. And from a cost perspective, you be very thoughtful about when to scale back, because that really does give you an opportunity to tune and improve your workloads there.
And speaking of auto scaling rules, one of the challenges I've seen is people don't set the scale up and scale down rules differently. They just include overlapping conditions on both scale up and scale down rules, scale out, sorry, and scale in rules. And what happens is essentially I don't remember the error that it throws, but it kind of goes into a throttling mode. Yeah, I think Jason posted a good a link down there. If you will go to that link, I believe they do mention how to define those rules.
Nice, thank you.
If I can jump in here, as long as we're discussing this, something I've found as I've dug into this is people really don't take the time to understand the performance indicators and where the bottlenecks really are for their application. They don't understand what's going to break first. Oftentimes, for example, network is something that I see as kind of the threshold as far as how many open network connections. It's kind of this little silent thing that is each workload that you have in Azure has a limit of open network connections, and sometimes that can be the big thing. But to me, it's testing is really important, and making sure that you understand what happens to your workload when a certain volume of usage comes to play. Is you should understand where it's going to break first, and that helps you then figure out how to set up your scaling appropriately.
That makes complete sense, and that sort of goes in with performance and optimization, just in terms of finding the breakpoint of each of the components within the system. And certainly the weakest link has to be known, and so does every other link for that matter, but certainly the weakest one does. Yeah, thank you.
All right, the next pillar on the list is reliability. In one of the starting slide, I did ask about the greatest fear that IT teams can have, and someone answered outage, and that's what is the right answer. I mean, the fear of system going completely down without being recoverable is one of the top fears that IT teams have. And most of the businesses are now going digital and global now, and any of these businesses cannot really afford systems going down whenever there is a failure or an outage. So the reliability pillar under well-architected framework does addresses that concern. It provides guidance on how you can make your environments fault tolerant. It helps you make your applications resilient and highly available so that they can handle both localized and broad impacted incidents. If you think about it, it is actually a very critical aspect that downtime directly hurts revenue. Imagine an e-commerce website, if it is down for half a day, how much revenue it might lose. The reliability pillar doesn't say that you should not expect failures. Instead, it says otherwise. It says that failures are inevitable. No matter how much prepared you are, failures are bound to happen. No cloud provider, as I was saying earlier, provides 100% SLA for any of their services. So the maximum that you can get is 5 nines. So what really matters is how prepared you are in case something fails. Now it could be any component of your architecture that might fail. It could be compute, storage, networking, or your application code. Uh, it could any of those failures can result in your application becoming unreachable or unresponsive. Uh, it could be a physical infrastructure as well. Sometimes physical hard drives crash, or anything might happen. So there are a couple of principles that reliability pillar under well-architected framework offers that you must consider while you are thinking about reliability for your environment. The first one says that you must build a highly available architecture, meaning when you are designing your environment, always consider the SLA offered by Microsoft for the specific services. If it doesn't meet your business continuity requirements, you must plan for high availability by adding appropriate redundancy in your architecture. And the other principle speaks about recovering from failure. As I said earlier, failures are inevitable. So you must design your environment so that it can recover gracefully whenever a failure occurs. As a best practice, I can say you should always have RPO and RTO defined for your workloads. So RPO refers to, if you're not aware of, RPO refers to the maximum duration of acceptable data loss. It is measured in units of time, for example, 60 minutes of data or 1 day of data. Likewise, recovery time objective refers to maximum duration of acceptable downtime, meaning if the acceptable downtime duration is 4 hours, then your RTO is 4 hours. Defining RPO and RTO for your workloads can really help you in designing the right capabilities in your architecture. And once you have RPO and RTO defined, you can go back to your architecture, fetch the SLA numbers for the services you are going to consume, and see if that's going to satisfy your business continuity requirements or not. And if not, then you should probably add appropriate redundancy in your architecture. Security is no-brainer. It's all about protecting the data that your organization uses, stores, and transmits. Data that.
Real
Sorry,
quick,
go.
sorry, one more question on our previous topic about
Sure.
reliability. Always super important. Trying to get the business to buy into reliable solutions. You know, we go to one Azure data center, and we've got reliability zones where things can fail over, but trying to get them to stand up things for a geolocated SQL database or other services. How do you go about helping to justify those costs? Because a lot of businesses are very happy to sort of just risk it and see how far they can go before they have an outage. I mean, I liked what you said about trying to impress to them that outages are going to happen, we have to plan for them. But so many businesses that I've either worked at or worked with are always happy to take that risk until the risk happens, and then it's the knee-jerk reaction if we have to fix everything.
I think that's where defining the RPO and RTO for our workloads play a key role.
Mm-hmm.
If you can get those RPO and RTO defined and documented somewhere, then based on that, you can design your architecture. If the RPO RTO lets you just run single instance, great. It might require you to run it in availability zones. It might require you to run multiple instances in same region or multiple regions. And the more instances you are going to run, the more it's going to cost. So I think the key point here is get RPOs and RTOs defined for your workload with your product teams. And if they are not ready to pay for the additional cost, then they should probably change RPO and RTO for their workloads.
That's the battle sometimes, is they want a recovery time that's not possible without high availability, but they also don't want to pay for the high availability. It's just something I've come across a couple times with different customers where they feel like they can get away with it, and I don't know, I guess it's just trying to tell them RPO and this could happen eventually. It's all future possibilities that they are. It's always a hard and tough sell, I think.
True, that's true.
I don't mean to interject again. I think one key point is that we do this evaluation per workload, and so being very very key or focused on which are the critical workloads, and whether it's only preserving data because you can endure extending outages, and really where to spend that money, and understanding there are high value workloads and there are low value workloads, and so you don't need the same expectation for all of them. To really tell them where the golden eggs are, if you think about it that way. The other thing,
you have your tiers of workloads, you have your tier 1, tier 2. These are things that we have to have an RPO of X, and the other things are ancillary. They could be down for 2 days and no one's going to notice. I definitely agree. That's a great way to try and break that down the cost wise. It's just, I feel like that's always been the hardest thing, and maybe it's just the customers I've worked with. It's always the hardest thing to try and get them to jump on that, and just maybe looking for some insights on pushing that topic in a different way.
And I can relate to that as well. I've seen teams who first don't really understand that they might need that level of availability, but when outages happen, they are the first ones shouting and screaming.
Right. So. Yeah. Okay. Excellent. Thanks.
All right, security. So as I was saying, security is no brainer. It's all about protecting your data that your organization is using, storing, and transmitting. So the data that your organization stores or handles is as the heart of your securable assets. So now the data exists on some kind of infrastructure, which also needs to be secured along with the identities that are used to access that data. It is highly important to have your complete security posture tied so that your data is safe and secure when it's sitting out there in Azure. There are a few key principles that you might utilize here. To start with, you must develop a defense in depth approach to securing your architecture. I have one slide just after this one to talk about defense in depth in detail. But in a nutshell, it requires you to make all the layers of your architecture secure. The other two are straightforward. You must choose the right set of technologies to secure your Azure resources. It could be as simple as utilizing network security groups or using Azure Firewall. And as I said earlier, it is important to secure the identities as well that access your data. You must leverage industry best practices for managing your identities. You can utilize features like Azure Role-Based Access Control to restrict access to your Azure resources, privileged identity management to manage control and access to important resources in your environment. You can integrate your applications with Azure Active Directory for authentication and authorization and so on. Let's talk about defense in depth. If you have not heard of it before, here it is how it looks like. It's a security risk management approach that defines multiple layers of security controls in an IT environment, so that if a security attack is not caught by one layer, it will probably be caught by the next one. The multiple layer increases the overall security score of your environment, and it essentially reduces the probability of a security breach by a huge margin. Sometimes defense in depth security model is also referred to as castle defense model, as it resembles the security defense techniques that were employed in historical times in castles, where if an enemy had to first cross multiple barriers at the castle's periphery before attacking the actual castle. So with the rapid expansion of cloud computing, the need for defense in-depth strategy has increased manifold. I would be surprised if we would not have heard of security breaches in the past uh, year or so. And what you're seeing towards the left is a snapshot of the different security layers that exist in a cloud environment. At the core is the data, which must be encrypted both at the rest as well as at transit. The next is the application, where you must secure your application access by using services like Azure Application Gateways, Web Application Firewalls. The next layer is your compute layer, which runs your applications. Your compute layer must be protected against threats like RDP, brute force attacks, SQL injections, and so on. You can utilize Azure Security Center to generate a secure score and assess your overall security posture in Azure. And then comes your network, which enables different components. What enables your different components to interact with each other? It is no brainer that you must secure your networks, and for doing so, you can utilize services like network security groups. Then comes the perimeter, where the most common form of attack is distributed denial of service attacks. Azure comes with basic tier of DDoS enabled by default, but you can also opt for standard DDoS tier for additional support options. Then is the identity. As I was saying, identity is the new uh, security perimeter. So ensure that you have secure identity system in your architecture. And lastly, the access to the physical data center must also be authorized. And since it's a public cloud provider, it's being managed by Microsoft or Azure, who doesn't let any unauthorized professional to access any of the data centers in person. So what you will realize here is that this is where the responsibility, the shared responsibility model comes into play, where some of the security responsibilities fall onto our shoulders and some of them have to be fulfilled by cloud provider, Microsoft in this case. So here's the model of the shared responsibility model that I have shown in the starting of on-prem IaaS, PaaS, and SaaS. This is how if we have to reframe it in terms of security. Depending on the type of the service you select, some of the security is already built into the service by cloud provider, whereas other remains your responsibility. As you can see, it is absolutely essential to use the right set of services with the right security controls to ensure that you maintain an overall security posture in the cloud. Any questions so far about security? The shared security model? Okay, so we did cover all the 5 different pillars: cost optimization, operational excellence, performance efficiency, reliability, and security, and some of the key principles that fall under each of those pillars. But what you would have noticed is there is always a trade-off between cost and rest of the pillars. And as I've said earlier in the initial slides, that there is no one size fits all approach when it comes to the cloud architecture. The 5 pillars we have talked about offers the guiding principles that we can consider when we are designing our cloud environment. And cost does plays a key role, as I was saying in the cost optimization slide. So regardless of whichever other pillar we focus on based on our business use case, it might be reliability or performance efficiency, security or operational excellence. Any changes that we'll make in architecture, it will impact our overall Azure spend. For an example, to make our systems more reliable, we must introduce redundancy. As I believe Kevin was mentioning about, we can introduce features like availability zones or regional redundancy, geo redundancy, and so on. But each of those features comes with an additional cost. So, and the more the number of resources you consume, the higher the cost will be. And Microsoft is going to charge you for that, regardless of if you are using it or not. The moment you provision it, your billing cycle starts. So it's a kind of balancing act, in my opinion, between cost and the rest of the pillars. You must always consider the trade-offs between cost and the other pillars whenever you are architecting your cloud environment. And that is where, Kevin, I hear you when you were saying that's where the struggle is, because people don't understand. They want to keep their cost lowest, and they also want their applications and workloads to be highly available, reliable. They should always available 24/7. So it's a balancing act which we have to work with a business and get them to understanding that what's important to the business. Is it cost, or is it business continuity, or performance, or security? What is that? So once you have identified the business priorities and the trade-offs, I think the only thing we could do is always focus on optimizing your costs. There are always pockets of areas where we can go ahead and optimize our overall spend. So that's pretty much that is there that I can brief about the 5 pillars. So now think about let's talk about how to get started. When we understand those 5 pillars, how do we get started? So on top of those guiding principles, Microsoft also offers an assessment review, which I was mentioning earlier as well, which you can take yourself for your environment. It essentially is a set of questionnaires targeted for different pillars. As you can see in this slide, all the 5 pillars are listed. You can go and assess your environment against all the 5 pillars, or you can choose whichever you would like to. And once you provide the required information in the questionnaire, it generates a score of where your environment stands and under each pillar that you have assessed for. And it also shares a set of recommendations. And once you will execute your assessment, will be the outcome of that assessment. It will give you an overall result saying where do you stand. Is it excellent? Your state is excellent or moderate or critical, and what categories are influencing that score. For example, the screenshot that I have just run the assessment for cost optimization pillar, where I stand in moderate state, but you can go ahead and execute your assessment for all the 5 pillars and see where your environment stands for. Let's quickly go to browser once and I will show you. So as Microsoft has provided a good documentation on well-architected framework. To read more in depth, head out to Azure Architecture Center. Under Azure Architecture Center, there is a separate section for Azure Well-Architected Framework. Under Azure Well-Architected Framework, you will see all different 5 pillars that we have talked about. And they also have different pillars. I did pick up top few of each of them, but there you might find few more principles and guidance on how you can implement the individual pillar in your architecture. And this is where the review is. If you'll head out to the well-architected framework, they have provided a link over here as well. If you will head out to it, you can create your own well-architected review. For example, if I just go ahead and do it for cost optimization and click next, it will start asking me certain set of questions in regards to that particular pillar. And once I'm done with all those answers, as you can see, it's expecting me to answer roughly around 8 or 10 questions for cost optimizations. Once I answer them based on best of my knowledge on my environment, it generates the score on the slide that I was showing, a slide something similar to this. And as I was saying, you can do it for all the 5 different pillars. Another tool that you can leverage is Azure Advisor. It analyzes your resource configuration and usage telemetry. It does recommend solutions that can help you improve across your 5 pillars. As you can see on the screen, it is showing 5 different wizards for each of the pillars. It is, for example, if you will pick up security, it's saying there are 31 recommendations under security pillar. 20 of them are high impact, 7 are medium impact, 4 are low impact. I can further go and drill into each of them. I'm sorry about this screenshot, looks like it might be blurred, but once you will go under each of those sections, you can see on the top here you have high availability, security, performance, cost, and you can see the set of recommendations under each of those pillars and the impact they have. Recently, Microsoft has also announced, I believe it is not in preview anymore, but what you can also see is an advisor score against each of the pillars, and it also gives you a total score where you stand against 5 pillars of the well-architected framework. It does runs against your Azure environment and gives you a real-time score on where do you stand today. One of the good features that I have liked is, for example, under cost, it does list all the 5 different recommendations that it has, and for some of those recommendations, it also offers something known as quick fix. What happens is if you will click quick fix, it goes ahead and make the appropriate changes that needs to happen. And if I go ahead and head out to Azure portal, so I don't run much in my Azure personal subscription, so that's why you are seeing under Azure Advisor, I don't have any recommendations under cost, operational excellence, performance, and reliability, but there are 3 recommendations it's making under security, and looks like there is one resource, one subscription on which it is giving me that recommendation. For example, I have more than 3 owners designated on my subscription. So it's saying you should not have more than that. External accounts, I have added external guest accounts to my directory, so it's saying you should not have that, and it's just saying MFA should be enabled. So likewise, it does offers different recommendations. I can go under each of the pillars since I don't have enough workloads running here. That's why there are not many recommendations here. And here's the advisor score. It looks like I'm 88%. So if I'll go here, it looks like I was roughly around 64% back in February. And I've reached 88% starting April. Moving on, Microsoft has also provided a good chunk of design patterns, which can be very useful in designing your Azure environment and workloads. In accordance with the well-architected framework, each of these patterns describe the problem that the pattern addresses, considerations for applying the pattern, as well as some of those patterns also give examples on how you can implement the pattern in Azure. Most of the patterns might include code samples or snippets that show you how to implement the pattern in Azure. If not code sample, at least it will give you a reference architecture that you can have a look at how you can implement the pattern on Azure. Do note that most of these patterns are applicable to any distributed system, whether hosted on Azure or AWS or any other public cloud. So if you'll head out to Azure Architecture Center, under Azure Architecture Center, where you have find Azure Well-Architected Framework, here are the different cloud design patterns that you can look out for. So there are some design patterns around things like reliability. Oops. Oops, I'm not seeing those. But here are all the design patterns that you can find under the Azure Architecture Center. In addition to Azure Well-Architected Framework, you can also leverage a cloud adoption framework to better align your business and technical strategies. It provides best practices, documentations, tools that you can use to successfully achieve your objectives on migrating to public cloud. In addition of the well-architected framework, there are some consistent design patterns that you can consider throughout your architecture. Number one, there is no architecture that is static, so always opt for evolutionary architecture. Allow for the evolution of your architecture by taking advantage of new services, tools, technologies whenever they are available. You should base your decisions on data. Always take data-driven decisions. From cost data to performance to user load, using data will actually help you to make the right choices in your environment. Educate and enable cloud technology evolves quickly, so educate your development, operations, business teams to make the right, to help them to make the right decisions and build solutions that solve the business problems. document, share configurations, decisions, and best practices within your organization. And last but not the least, we did cover automation in the operational excellence pillar as well. Automation of manual activities reduces overall operational cost. It does minimizes errors introduced by manual interactions, and it does provides consistency between environments because you can achieve repeatability using automation. So, all right, we have talked a lot in last, I don't keep a track of the clock, but I think roughly an hour. I would like to conclude with an overall summary of what we have discussed so far. Architecture is a foundation of any workload, any applications design. Using well-architected framework, you can get the confidence that your application can sustainably meet the needs of your customers, both now and in future. The architectural priorities and needs for every application is different, but the 5 pillars in the well-architected framework provides excellent guidance and guideposts that you can utilize to improve your overall architecture. And as I was saying initially, focusing on these pillars can ensure that you are laying a solid foundation for your workloads running in the cloud. And with a solid foundation, you can drive innovation, build solutions that your users will like, and it will also foster trust. Here are some of the resources that I have utilized for the presentation. I will be sharing this slide deck with Kevin and Cameron. They can share it with you all. So you can go through these links. Most of these are from Microsoft. So all the information is available in public domain. You can Google it yourself. And these are some of the great resources you can utilize for further reading and developing an understanding on the well-architected framework. And with that, I can open the floor for any questions that anyone might have, or we can discuss anything else as well. And if not, I can conclude my presentation. And if whenever you will get the slide deck, I do have my Twitter and LinkedIn links on the introduction slide. You can reach out to me if you would like to talk to me offline. So if no more questions, Kevin, Cameron.
No more anybody questions?
There's one in the chat.
Oh. For the Azure Migrate, Azure Marketplace lists third-party tools for assessment and migrate. Any suggestions, third-party tools?
I don't have any suggestions, unfortunately.
Yeah, I'm not sure either. You know, some of the migration tools I've used for some of the things from Azure, Azure has actually gobbled up some of those companies. So, you know, MoveAir, you know, was one that they gobbled up not too long ago for moving VMs out to the cloud. But a lot of native tools, even that exist in Azure for migration, are extremely helpful. From like the data migration assistant. Recovery for VMs if you're going infrastructure to infrastructure, even a tool that's publicly available that you can run on any web application to say how likely is it that I can run this on an Azure app service. So Microsoft themselves, I'd say, has most of the tools that I've probably used in the past to help out with that.
And I've personally found those tools super helpful.
Yeah,
so I said I don't have any recommendations because I have not used any third-party tools myself.
Yeah, anybody else have any suggestions outside of the Microsoft tools?
Same here. I find the tooling that Microsoft has provided to be pretty solid.
Mm-hmm. Okay, one other thing. On the security layers slide you had provided to read about this, can you post it in the chat? You provided a link to read about.
I can do so. 1 second.
Any other thoughts, questions?
Are you pointing to this one?
Yeah, that's it. Hi, I'm Jennifer Chang.
Uh-huh.
I didn't
Yeah.
get a chance to do the polls at the beginning, but I would rate myself a 1 for Azure. I work with a lot of architects, but I'm trying to come up to speed.
This is a good way to do it. Everybody's got to start somewhere.
By no means, when I posted that link down there, I'm trying to endorse my blog, but that's my blog, so I find my blog post good for anyone who is trying to understand what defense in depth means at a beginner level. So I did posted the link on the chat.
Perfect.
And frankly, I think you can endorse your chat. It's acceptable. All right. Well, thank you so much. Any other questions, I guess, before wrap up?
So one last question for, say, an organization that's getting ready to move to Azure, or someone who's been in Azure but is now beginning these assessments. How much of this should they bite off? Should they try and investigate this a pillar at a time? To move into this framework would consist of a lot of time from all the teams, and not to scare anyone away that, oh, we're going to spend the next 4 months going through and working through this architecture framework.
Good point. So my suggestion has always been it's a set of guiding principles. It doesn't mean you have to implement each and everything that it says. It tells you best practices across different pillars. So what you might have to do is identify what pillars are more important to you in your use case, in your architecture, and then prioritize based on that. Because as I've said, there is no one size fits all solution here. There is hardly any use case out there which will need all 5 pillars to be equally strong. So there are chances you might need cost optimization and reliability probably, or security. So whatever is your priority, start with those pillars and then go ahead and review the other pillars as well. That will give you, you might not be required to implement all the best practices in rest of the pillars, but it will give you some more point as to what else you can do to improve your overall architecture without deviating too much from your overall business use case.
Yeah, it'd always be nice to implement all of them, but it's either trying to fit in the time and get that. I feel like if you can get some early wins, like cost optimization is a big one, right? You go through that pillar and you show that, hey, working with this framework, we're able to save this much money and maybe time. Let's continue on through it. Just trying to sell the business and maybe the rest of IT that this is a worthwhile endeavor to invest some time into, because everyone has to be on board with that, right? To make sure it happens.
So there was a slide actually in there about the cloud adoption framework, which my team also built. And the cloud adoption framework is actually a really great way for the organization to think about moving to the cloud. And the well-architected is really a tool for all of the, I'm going to say, end developers to make sure that their choices are all in line with the business values. And so that it's actually a much more distributed model. And you'll see in the cloud adoption framework, they talk about training and skilling and things like that. And one of the things you might want to do is think about how you can get your delivery teams to think about solving their things using the well-articulated framework. So rather than run that with each of them, you build that as a skill that they have and do that in a more distributed way. And that way, when you have policy and things in place to identify overspend, everyone's operating on the same page about how they think about solving that problem. You did say you were early, and this is completely unsolicited, but make sure they have a tagging strategy before you go too far down that road. Otherwise, it goes bad.
Yeah, tag at the start.
You stole those words from my mouth. I was going to say the same thing about the cloud adoption framework. So thanks, Jason.